Okay guys, here's your little video over the Socrative quiz from last week so that you can use it to prepare for the day 2 part of the test on Monday. Alright, number 1, what is the surface area of a sphere that has a volume of 10 2/3 pi inches cubed? So what I did here is I started with the formula for volume since that's what's given to me. So volume is 4/3 pi r cubed. So I went ahead and converted 10 2/3 over to 32/3. That way everything would be an improper and it would be a lot easier to do. So 32/3 pi is what was given to me. I set that equal to the formula. So then I need to solve backwards for r. So I multiply by the reciprocal 3/4 so that these would cancel out. And I did it on the other side. And the 3's cancel out. 32 divided by 4 is 8. And then same thing, the pi's will cancel out too. So I'm left with r cubed is equal to 8. Remember, r cubed just means something times itself 3 times. So the only thing, 2 times 2 times 2, that's how I get to 8. So that's how I know that my radius is 2. Now I take my radius and the question's asking for the surface area, so now I plug it into the surface area formula, 4 pi r squared, so I plug in the 2 and there's your 16 pi. Okay, number 2, some people during the quiz were having a hard time visualizing. I can't really draw it for you in 3D because you've seen my 3D drawings. But if you draw it in 2D, it's kind of the same thing. A sphere inscribed inside of a cube is the same thing as a circle inscribed inside of a square. So basically the circle just fills up as much of the square as possible. So if this has a radius of 8, well then if I had the other radius on the other side is 8. That means the length of the square is 16. So when I find the volume of a cube, it would be 16 times 16 times 16, which would be 4,096. When I combine that to a sphere, 4/3 pi r cubed, remember the radius was 8. So I plug in 8 and I get 2048 over 3 pi. So now it just says let's find the ratio. Well, ratio is nothing more than a fraction. Compare one to the other. So that's what I did over here. I said, okay, I have 4096 from the cube, and I have 2048 over 3 pi for the sphere. Well, look, 4096 divided by 2 is 2048. So this one is twice of this one, and I still have the divided by 3 and I still have the pi. So if I just, basically, if that's not making sense, if I divide this by 2048, I get 2. If I divide this by 2048, I get 1/3 pi. And so that's the ratio in its simplest form. Okay, surface area of this composite figure right here. I'm going to make it as big as possible where you can still see the picture. Okay, so for surface area of this thing, I have 2 laterals for the cone, one on the top and one on the bottom. So they're the same formula, the cones are the same dimension, so I just said I'm going to do it twice. Plus the lateral of the cylinder. I don't need any bases here because there aren't any. They're all shoved together. So 2 pi r L plus 2 pi r H. And then just plug in and go. The radius is 8 and the lateral, the slant height is 12 for the cones. The radius is 8 and the height of the cylinder is 16. These are all in terms of pi, so just tap, tap, and you get 448 pi. Same story for the volume, but before I can do, so same story for the volume. So I have 2 cones for the volume plus the cylinder. So 2 formula for volume of a cone is 1/3 pi r squared h, and then the cylinder is pi r squared h. I can't put these together yet because they have different heights, though this one will have a different height than this, so I need to keep them separately. Now they all have the same radius, but different height. Speaking of height, remember the formula the problem gave you for slant height, and you need for volume you need vertical height. So I got to do Pythagorean theorem. So if the slant height is 12 and the radius is 8, this one I told you could enter into your calculator, so you can just get a decimal and you get that decimal of 8.94. So then I plug in 2 cones at 1/3 pi, the radius is 8, the height we just calculated is 8.94, plus then the cylinder pi r squared h. Tap all of that into your calculator and you get 4415.3. All right, this guy right here. So it told you what was happening in the problem. You just kind of had to make sure you could visualize it and understand. We have a big rectangular, oh, I didn't mean to be drawing. We have a big rectangular prism that is 40 by 38 by 15. And then we cut out a small rectangular prism on the bottom, and we cut out half a cylinder. You kind of have to think that it's laying on its side, because if you had the whole cylinder, it would be right here, but you cut it off on the flat part. So that's exactly what I did for my formula. I want to do the volume of the big prism minus the volume of the small prism at the bottom minus half the cylinder right there. So prisms, length times width times height, half of the cylinder pi r squared h. So the big prism is easy. They gave it to you, 40 by 38 by 15. The small one is 18, and I know that because the whole way across is 38 minus 10 minus 10. That leaves 18 for the opening right here. So 18 by 12, and this is still 15 from up here. That's 15. And then the cylinder 1/2, if this is 18 all the way across, then the radius of the cylinder must be 9, and the height of the prism is still that 15 going down. And so then I just type all of this into my calculator, and I get 17,651.48. Okay, last two. This one was just find the plan, as it were. So I'm doing surface area, so I need the entire surface area of the big cone because I need the lateral around the outside. I also need this area right here on the top, so I'm going to need the total of the big cone. Now when I cut a hole right here, that is the small base being cut out, so that's why I'm subtracting a small base, because that's the hole. Well, when I cut that hole away, I am exposing the lateral part of the little cone. So now that it's exposed to the air, I have to add the lateral of the little cone. So I want the total of the big cone for all of that around the outside plus this around the top. The lateral of the small cone, because this is all open to the air on the inside, but this hole I cut out is the small base right there. Okay, last one, the surface area of this figure right here. So I know I need the total of the prism, and I have this hemisphere on top right here, but what you have to remember about a hemisphere is that you've already cut that in half, so there actually is no bottom to the hemisphere. Remember when we were doing that worksheet in class, the 10.8 worksheet about chocolate pie or whatever it was, when we had a hemisphere and we needed the bottom, that is a terrible picture, but you get what I'm saying. We needed the bottom. Remember, you had to do 2 pi r squared for the hemisphere, and then you had to add on a pi r squared for the base because that is not included. So in this case, I don't need to add on this pi r squared for the bottom because it's not getting painted. So I did the total of the prism plus, oh, sorry, I'm doing crazy things over here. The total of the prism plus the outside of the hemisphere. Then, if I were to take off the top of that prism, there would be a circle that was not painted if you were. So I have to subtract out one circular base because that's not going to be painted. I'm not subtracting 2 bases because the hemisphere never had a base, so there was nothing to take away from it. Okay, so then when I go and plug in my formulas, perimeter h plus 2b, 2 pi r squared for the hemisphere, but minus a pi r squared for that base that did not get painted on the rectangle, that circle. So the perimeter, this figure is 10 by 5, so 2 10 by 5s plus the height of, or times the height of 4 rather, plus 2 bases, so the bases are 10 by 5, so 2 bases, and then I just did 1 pi r squared, because if I had 2 pi r squared minus a pi r squared, that just left me with 1 pi r squared left. Type all of that in, 298 and a half. Hope this helps. Have a good weekend.